Hey guys, this is the Black Ombre.
And I'm Roasty.
We're the developers of the Smash Stick. As stated in our last video, we've been attempting to work on an amendment proposal with the goal of providing a concise definition of legal alternate controllers and controller mods.
Unfortunately, while doing this, we realized the importance of making this rule set stable. Stability matters to everyone. To an alternate controller maker such as ourselves, it matters because the creation of controllers is an incredible investment of both time and money. For TOs, it determines which players can legally participate in their tournaments. And for players, it determines what tournaments they can legally attend. At the end of the day, legality affects everyone.
In order for a rule set to be stable, one must take proper care of specifics as they do not account for all scenarios. Right now, there are a lot of misconceptions regarding controllers, in particular, analog to digital converted, or ADC buttons. This concerns us regarding legality since the Smash Stick's C-Stick and Light Shield are ADC buttons. With that in mind, today we intend to talk about ADC buttons.
Before we can expand into the topic of ADC buttons, we need to define some important terminology. The GameCube controller, or the GCC, sends all communication to the console via data line wire inside the controller's cable. This data line is an 8-byte digital signal that contains two types of inputs. The first is a digital input, which is a 1-bit signal. This means that the console reads it as either 1 or 0. The GCC digital inputs are start, A and B, X and Y, L and R digital press, Z, and up, down, left, and right on the D-pad. The second type of input is an analog input, which is an 8-bit signal. This means that's a numeric value ranging from 0 to 255. Every analog input that the GCC performs is converted into this 8-bit signal. To give you an idea how this works, 0 would be left, 128 would be center, and 255 would be right. The GCC analog inputs are X and Y axis on the directional stick, X and Y axis on the C stick, and left and right analog triggers.
We mentioned earlier that an analog input is a number from 0 to 255. In other words, only one number can be sent to the console for an analog input. Because of this, for a controller to have ADC buttons, it needs to be designed to take into account what happens when you press two simultaneous opposing cardinal directions, or SOCD. An example of this is pressing ADC left and ADC right at the same time. This is important because the Smash Stick can do this with its C-Stick buttons. The four current known solutions to this problem are SOCD creates neutral input, SOCD prioritizes new input, SOCD prioritizes old input, and SOCD results in same input every time. For directional ADC buttons, SOCD neutral and SOCD prioritize new are the most popular. In comparison of the two, SOCD neutral gives more access to pivots at the expense of less access to dash dancing, while SOCD prioritize new gives more access to dash dancing at the expense of less access to pivots.
The SOCD scenarios mentioned earlier are examples of modifiers. A modifier is a combination of buttons that give a different output than when pressed independently. The order of buttons pressed can change the modification at which occurs. By using modifiers, the Smash Stick is able to perform angled forward smashes with the C-Stick buttons. Normally, from pressing two non-opposing directions, such as up and right, you would get a 45-degree angle. However, to perform an angled forward smash, a much more horizontal angle is required. To do this, the y-axis value is set to be modified when these two directions are pressed simultaneously, which results in the desired angle. A modifier doesn't have to be specific to ADC, however. The Smash Stick also uses a toggle button that changes the C-Stick from being buttons for the C-Stick to D-pad buttons. For Stickless Controllers, aka a box-style controller, modifiers are a must to retain the input accessibility of the analog stick. For example, a modifier can allow for a button to change another button from inputting a dash to walk by changing its x-axis value. Using a different combination of x and y analog values, you can obtain different angles. This is where a lot of the conflict within the community arises. Which analog inputs are considered fair for competitive use? The popular opinion is that ADC buttons should be limited to what GCC notches can do. The logic behind this is that notches are a consistent way to hit a specific combination of X and Y analog values on the stick. The truth is, however, that notches cannot hit an X and Y analog value with 100% consistency. This is due to the analog stick possessing a large resolution, GCC notches wearing down over time, and the ability for the GCC to change values just from twisting the stick box. Because of this, respected modders such as Cardinal will center their perfect wave dash notches to be slightly less than the optimal angle. Doing so, the notch consistently hits a range of values that are close to the perfect wave dash, but are far enough from the cardinal direction to prevent a missed wave dash. For this reason, many argue that stickless controllers should not have a consistent means of inputting the optimal wave dash angle, as this negates the risk of approaching the angle on the GCC. The proposed resolution that the community members have is that stickless controllers should be nerfed to using the analog value that wave dash notches on the GCC are centered at. However, the conundrum that occurs is that, unlike a GCC notch, ADC buttons will always have a 100% consistency, regardless of which analog value is assigned to it.
The ability of an ADC button to always result in the same analog value means it can consistently hit notchable values with single value precision, regardless of the risk on an analog stick. The smash stick C-stick buttons are an example of notchable values with no significant risk involved that have single value precision. 1.0 dash on stickless controllers is also an example of this, since for the most part, the risk of being slightly off of 0.9875 is negligible in game. There are other notchable values such as SOPO desync jump and SOPO desync dash on the directional stick, and SOPO desync forward smash on the C-stick that have significantly less risk compared to the wave dash example. The fact is, no matter what the value is, ADC buttons have the ability to always result in single value precision, even if the value is not notchable. As mentioned earlier, analog inputs can have values that range from 0 to 255. This range also includes unnotchable analog values. The smash stick, for example, has a light shield button that, when pressed, inputs the maximal analog shield size. Much like slow walk, which does not normally extend to the GCC gate, this value cannot be notched without limiting the full range of the potentiometer. However, these unnotchable values are not limited to just the directional stick. The C-stick has unnotchable values for SOPO desync up smash and down smash. While many players consider these values inaccessible, players such as Fly and Munita have shown with proper calibration these values can become accessible on the GCC. To do this, player can use the C-stick to line up the character select screen, recalibrate, and every time they let the stick return to center, this achieves the desired value. When you consider all the values that an analog input can provide, it's not unreasonable to consider that the community may find more values of importance, much like desync up smash and down smash. If a rule set is designed based off specifics such as these values, then its inherent subjectivity will cause it to be unstable. This is because Melee is constantly being researched by the community, and we never know when the next big exploit will be found.
One of the most controversial topics regarding ADC buttons is the possibility of an SDI button. While the concept of an SDI button provides concern to many, when broken down, you realize that this is the same technology used in the smash stick C-stick buttons. By having a button that modifies an analog input, such as the directional stick's y-axis value, you could alternate between up and down with the press and release of a button. To give an example of how a player could SDI to the right using ADC buttons, on frame 1, you would press right. On frame 2, you would hold right and press up. On frame 3, you would continue holding right and up and press the y-axis modifier button. The modifier decreases the y-axis value to down, creating down right. On frame 4, you would continue to hold right and up and release the y-axis modifier button. This would revert back to the higher y-axis value, creating up, resulting in an up right. And on frame 5 and beyond, you would repeatedly press the modifier button as desired to continue obtaining SDI inputs. Now, without proper explanation, many players may consider this button to be performing something completely different than what we previously mentioned in this video. However, the conundrum of banning such a button is that it's nothing more than a notchable modifier with no risk surrounding its single value precision, just like the nerfed wave dash angle the community has called for. And while you can't SDI with a C-stick, it's important to remember that this is the same technology that allows the smash stick to achieve the angled forward smash mentioned earlier.
As we mentioned before, we've been struggling to write a concise rule set that will stand the test of time. If such a rule set is not created, then not only will alternate controller makers be prevented from investing in the Melee community, but players and TOs will be negatively affected as well. And the only way this can happen is if the rule set is made with a complete understanding of the information surrounding controllers. Over the course of this video, we've gone into great detail on how ADC buttons work, and while we received an overwhelming amount of support regarding this match 6 legality, it's important to remember that our controller also uses ADC buttons. So if you want our controller to be legal, you can't ban ADC buttons. Furthermore, if you want a rule set regarding ADC buttons to be stable, then there's no point in banning specific analog values.
We hope our video can better educate the community when engaging in legality discussion. As such, we plan to make a video in the future discussing harbor mods, since we feel this is also a topic of great importance regarding legality. In the meantime, we'd like to hear your thoughts on how we can go about writing this rule set on ADC buttons. Thanks for listening, guys. We'll see you around.